We are focusing on question 4. Right, so we have that this circle here with center F has the equation x minus 3 all squared plus y minus 1 all squared is the square of the radius. S is a point on the circle with center F. You can see the point S, here it is. Right, another circle with center M, with center G, excuse me, with coordinates M and N in the fourth quadrant touches the circle with center F. Okay, you can see these circles touch each other at the point H. All right, so at H such that you have that FH. Okay, so you have this condition that FH, the ratio of FH to HG is 1:2. Okay, so here is HG here, and the ratio is 1:2. The point J lies in the first quadrant such that HJ, here is the point J, it lies in the first quadrant such that HJ is a common tangent to both circles. So this one is a tangent, but a common tangent to both circles. Okay, both of these circles. JK is a tangent to the larger circle at K. JK is a tangent to the larger circle at the point K. Okay. Right, our next lesson is going to be on sides. So yeah, just to so that you're aware. Right, write down the coordinates of F. Right, so we need the coordinates of F. First and foremost, we know that the equation of the circle is x minus 3 all squared plus y minus 1 all squared. And this is equal to the square of the radius of the circle center F. And therefore, the coordinates of the point F would be 3 and 1. We're using the formula that x minus a squared plus y minus b all squared equals the radius squared. We'll always have the center with coordinates a and b. Right, so we have the coordinates of F, and F is the center of the smaller circle. Right, so we continue to do something here. We continue to do calculations. So we are now calculating something. What are we calculating? So we are effectively calculating the following, right? So we're calculating the length of Fs. Right, so we want to find now the length of Fs because we already know the coordinates of F are 3 and 1. So we're going to use the distance formula. So at this point, we can see that Fs, excuse me, so we know that Fs is given by, so we then say Fs is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Right, so if it's Fs, this one is going to be x1, y1. This is x2, y2. So what is x2? X2 is exactly 6. What is x1? It is 3 all squared. What is y2? It's 5. y1 is 1 all squared. And this is the square root of 6 minus 3 is 3. You square that, you get 9. 5 minus 1 is 4. You square it, you get 16. These become the square root of 25. And the square root of 25 is exactly 5 units. Okay, so we are interested in finding the length of Fs, and we can see clearly the length of Fs over there. Okay, it is actually is obtained right now. It is exactly 5 units. Okay, so we have found the length. We found the length by using something we call the distance formula. distance formula. Okay. We're good. The next thing we are going to tackle is the next question. The next question obviously is question 4.2, calculate the length of Fs. Oh, excuse me, we did that one. So we move to 4.3. Write down the length of Hg. Write down the length of what? Hg. Okay, obviously we know that FH, the ratio of FH, Hg is 1:2. So we want to find the length of Hg. So we know that the length of the ratio of FH, which is equal to Fs to Hg, this ratio is 1:2. The examiner gave there. Okay, so and the implication therefore is that if you have Hg, it is actually double Fh, and now that is the actual meaning of this, that Hg is actually double Fh. Yeah, okay, so I want to mention something here first, okay, in passing, just something so that you can just have an understanding of the ratios. We've done this in grade 9. All right, so obviously, if you have this, so you know that FH, so obviously I must indicate that FH and Fs are equal because they are radii. Each one of them is a radius, so we say they are radii. Okay, so now with this, it means Fh over Hg is 1:2. Now, at this point, if you cross multiply here, we're able to see that Hg is double Fh. What is Fh? Fh is equal to Fs, which is 5, and therefore we're able to see that this is 2 by 5 is 10. So that means Hg is 10 units. Okay, we're glad. Give a reason why JH is equal to JK. Let's see this. Give a reason why here is JH is equal to JK. All right, so this is something obviously you need to consider there. All right, so you know that according to the examiner, the point J lies in the first quadrant such that HJ is a common tangent. So we have HJ is a common tangent to both circles. There's also JK is a tangent to the larger circle at K. So this is also a tangent. This JK is also what? A tangent. Right, if it's also a tangent, then why are they equal? Why is JH equal to JK? Because both of these are tangents from the same point, and therefore they're equal to each other. Okay, so the reason why these are equal, because they're tangents from same point. And that is the reason. Tangents from same point. Tangents from same point are equal to each other. Okay, if you look at 4.5, you need to determine the distance Fj with reasons if it is given that Jk is 20. Determine the distance Fj with reasons. Right, so the distance Fj with reasons if it is given that Jk is 20. Okay, so let me clean up a little bit here the mass so that we can see what we're doing. Otherwise, we actually have created a mass, making it tricky for us to see very well. Right, so I don't want us to be working in an environment that is messy, it's uncalled for, and it is not the right thing to do, compromising our understanding, our ability to see and interpret. Okay, so we need to determine the distance, fj. So now we need to identify f and j, right? With reasons. If it is given that jk is 20, so you know that jk is 20 units. And then you need to find fj, distance from f to j. That's what you need to find. All right, so you can easily do this one. Let's get started. So we're looking at the answer to question 4.5.1. Okay, so to do this one, we need to realize that FHJ is 90 degrees. FHJ is exactly 90 degrees, like this. It's 90 degrees there. Because a tangent is perpendicular to a radius. So in other words, we know that FHJ equals 90 degrees. This angle is 90 degrees because tangent is perpendicular to radius. Okay, tangent is perpendicular to radius. Right, the next thing is to therefore realize that FJ squared is 20 squared plus 5 squared. FJ squared. Because these are equal, so this will also be 20. And we found the radius to be 5 there. So this is a right angled triangle. So it's like dealing with this kind of a triangle there, where this one is 5 and this one is 20. And then we have FJ squared. What is 20 squared? It's 400. Or this is going to be 425 if you add them up. So it is 425. And then we need FJ. Okay, if you take the square root of that one, it's the square root of 425. But it can be simplified to 5, the square root of 17. You can use your Casio calculator for that one so that we can see FJ is this. Then now this is 20.62. Okay, units. Right, so, and why is this? The reason is that here we're using Pythagoras. We're using Pythagoras theorem, and obviously we got FJ, which is what they wanted there. Okay, the next question is 4.5.2. 4.5.2 is this one. They're saying determine there the equation of the circle with center G in terms of M and N in the form that. Okay, so that is very, very easy. Let's check that. So just want the equation of this circle in terms of M and N. And what do we know already? Right, so we know a couple of things there. We know the distance from here to there, okay? We know the distance from here to there, of course, which is equal to the distance from here to here because those are radii there. All right, so at this point, if this is the case, then we are most certainly in business, okay? We're most certainly in business because we know HG. We know that HG is 10 units. And this hg, the distance from h to g, gives us something called the radius. Now, if we know the radius, we know m and n. So the answer to 4.5.2, the equation of the circle, would be x minus m all squared plus y minus n all squared is the radius. So it is 10 squared. And this can be written as x minus m all squared plus y minus m all squared is the square of 10, which is 100. Okay, so we found the answer there. All right. Now, we found the equation of the circle with center G. In terms of m and n, we'll leave it like that. Okay. Now, in 4.5.3, the coordinates of G, if it is given that the equation of the tangent JK is x equals 22. Okay, so let me clean this board up. This question was given a total of 7 marks, a bit more working is necessary there. Okay, we continue. Let me clean our board a little bit so that we are able to write with these. Okay, right, with these and be able to make progress, but also be in a position to work in a tidy place and be able to write on a clean surface. Right, so what does the examiner want? So they want us to do something here. Okay, we know the rest of the answers we got. We just want to answer this question. Right, we need to determine the coordinates of G if it is given that the equation of the tangent JK is x equals 22. Let's look at JK. So the equation of JK, this is J and that is K, and the equation is x equals 22. Okay, so this is obviously a vertical line through the number 22 on the x-axis. And then we just need to find the coordinates of G, okay? And G is the center. So we just need to find the coordinates of this center. All right, so let's actually get that one done. And once again, the billions of ways to do this one. Right, what are the coordinates of K first? The coordinates of K would be that X is already that because this line passes through 22, so X is already 22, and then at K, and then we actually need to find N there. All right, and now what else do we know? Right, we know that, for example, okay, let's do the question here, 4.5.3. Okay, so we're going to note that K, this is how I write the answer, has coordinate 22 and N. Also, it is clear that GK is equal to HG, which equals 10. It is clear that GK is equal to, GK is equal to HG, which is 10 units. We calculated that one. So it's 10, 10. It's the radius. Okay, it's the radius. Now, we are in business, and let's just get this question solved. Let's just get the coordinates of G. All right. But also we know that FH is equal to FS, which is equal to 5. FH. Right. So obviously at this point, we know that FH is 5, which is equal to FS, which is also 5. So these are 5 in there. Something we call, each one of them is a radius, so they're called radii. So we can then be in a position to continue now and find the required coordinates. For instance, what is m? What is the value of m? So we know very well that the distance from here to there is 10 units. And we know, therefore, that we are 10 units away from 22. So if x is 22 here, then you need to move 10 units backwards. What is x going to be here? What is x going to be here? So the x here is going to be actually the value of m. Okay, let's find that one. So obviously it is clear, therefore, that m will be 22 minus 10, which is 12 units. Right, so if H and G are collinear, so we note that if H and G are collinear, points on the same line. Right, why are F, H, and G collinear? They're on the same line. Now, the reason, obviously, is that H, J is a common tangent. The reason for this is that J is a common tangent. It's a common tangent. So now we are interested in finding, for instance, FG. Okay, so we're going to find FG. So the distance between F and G can be obtained, right? So the distance between F and G, so FG, you can find FG squared because you already know F. F has coordinates, we got them. What are the coordinates of F? We got them there. Center F is the equation, the circle with center F has that equation, so they're 3 and 1. The coordinates of G, the coordinates of F, excuse me, are 3 and 1. So we can find FG, and then now we are, that's one way to do the question. And then we're done with it. So, but you can just find FG squared with ease. It's just the distance formula. So we're able to see that one. So what are the coordinates of G? We already know M. M is 12 there. So we're going to put 12 here and then M. So if I give the 2 points, I give the point F with coordinates 3, 1. I give the point G with coordinates 12, N. And then x1, y1, x2, y2. The distance formula is always x2 minus x1 squared plus y2 minus y1 squared. What is FG? Is what we're looking for, but the distance between F and G, this one is 5 and this one is 10, and therefore FG is 15. What is x2? It's 12. x1 is 3. What is y2? So now we have 15 squared minus that. So 15 squared minus 12 minus 3 squared. This is going to be 144. You square both sides. Take the square root both sides. So that's going to be x minus 1 is plus or minus. The square root of 144 is actually 12. With that being said, we write the answer horizontally, so which means n minus 1 is 12, or n minus 1 is minus 12. Okay, which means n is 13 or n is minus 11. So the coordinates of G, therefore, are m and n. We've already seen that m is 12, and n can only be one of them. So obviously, n being the y value, it must be negative. So it can't be 13. So it can only be minus 11 because y is negative, and this is the y component. So we accept minus 11 there. Those become the coordinates of G. But they said there are billions of ways to do this question. Okay. Now, what else do we have? So we found the coordinates of G. Here they are, exactly 12 and minus 11. All right. Now, that was the second question, and then we'll move on to the triangle question. There's also a triangle question in the exam. Let's just recap on that. This one is not very difficult. I'm sure that you're very familiar with this, but we recap to make sure that you're at par with the exam expectations. In the diagram, we have K, L, and M are vertices of triangle that. So you have K here. You have K, L, and N are vertices of triangle KLN such that LKN is 78.69 degrees. KL intersects the x-axis at P, and KL is produced. The inclination of KN is theta. The coordinates of M are minus 3, minus 5. Right, so here they are. Okay. And then we we answer some questions. We need to find the gradient of what? We need to find the gradient of Kn. Right, so to find the gradient of Kn, it's straightforward. So we use the word gradient formula. So the gradient is clearly very straightforward there. Okay, so the gradient becomes change in y, change in x, change in y, change in x. So the gradient at this point, the answer to 3.1.1 would be the gradient of Kn is y2 minus y1, which is the change in y, divided by x2 minus x1. So at this point, if it is x1, y1, x2, y2, what is y2? Is minus 1. Y1 is 2. X2 is 1. X1 is minus 1. So this is minus 3 divided by 2. So that is the gradient of Kn. Now the size of the angle theta. Right, so the angle theta is that one. And we can roll to find its size. And to find that one, we use the following relation. We say the tangent of theta, at this point, tangent of theta would be actually equal to the gradient of the line that makes the angle theta, which is the line joining the points K and N. And therefore, this gradient is minus 3/2. Okay, if this is minus 3/2, you can be able to find theta. What is theta? So first and foremost, theta would be the same years. Okay, first, you need to find some reference angle. So you find a reference angle by saying arctan 3/2, which is what? 56.31 degrees. And therefore the angle theta, 180 degrees minus 56 31 degrees, which is 45 degrees. No, make no mistake here. Right, so 180 minus 56 is actually 123.69 degrees. Right, so that's the answer there. So we found the angle of inclination, the side of theta, the angle of inclination is 123.69 degrees. And then now we're looking at the next question, 3.2. Show that the gradient of KL is equal to 1. Right, now if you look at KL, want to find the gradient, you need to show that the gradient is 1, okay? So this is linked to the actual angle of inclination here, but now you already know the angle of inclination here, theta, how inclined this line is 123.69 degrees, okay? So this angle is equal to this plus that. So you can say the answer to 3.2, right? So you can create a little bit of space here and look at the answer to 3.2. So you first look at the fact that the inclination KL, right? So the inclination of KL is actually equal to KL is equal to the following. Okay, so to find that one, you can proceed like this. Okay, so you can do this there. Right, so that's fine. See the eraser. If I make it an area eraser, if I make it a stroke eraser, okay. Right, so I want to find the inclination of KL, and it's okay. But I want to mention something here. That the angle theta, so you can call this angle of inclination alpha. So you let the inclination of KL be equal to alpha. So that now you then say the angle theta is 78.69 degrees plus alpha. Okay, the reason for that is obviously we have an exterior angle. The triangle equals the sum of interior, sum of interior opposite angles. So the angle theta, we've already seen that it's 123.69 degrees, which equals 78.69 degrees plus alpha. The angle alpha is 123.69 degrees minus 78.69 degrees, and alpha is equal to. Okay, if you subtract now these ones, you get exactly 45 degrees. This is 69. Okay, subtract them, you get 45 degrees. So that now, if you want to find the angle of inclination there, you say, you want to find the gradient of KL. So you need to show that the gradient of KL is equal to 1. So you then say the gradient of KL is the tan of alpha, which is the tan of 45 degrees. And this tan of 45 degrees is equal to 1. So we've shown that the gradient of KL is 1. Okay, we've shown the gradient of KL is equal to 1 there. Because the tangent of 45 degrees is 1. We can use our special triangles there to see that. This one is 45 degrees, and that is 45 degrees. Square root of 2, 1, 1. Okay, this triangle is called isosceles triangle. So we're good. Now the next thing we need to do in 3.3. Okay, 3.3, we need to do a brief calculation there. So in 3.3, we need to determine the equation of the straight line KL in the form this. The equation of the straight line KL. KL, the equation of the straight line there. Okay, so we can be able to do that one. Right, so it's straightforward, that one, because we just need to find the equation, we need a point and the slope. So we can use any of the results we know. Right, so for 3.3, we need to use this line KL. We need to find the equation of the straight line KL in the form that, but we can see that KL passes through the point K whose coordinates we know. So it is through K. K has the coordinates -1 and 2. And then with that, we have y minus y1, which is m into x minus x1. Okay, it's the easiest one to use when you know the point and the slope. So we already know that the gradient of KL is 1. Right, so, but this one is x1, y1. Those are the coordinates. So we have y minus 2, which is the gradient m, which is 1, into x minus 1. So this is y equals, right, so you have x negative by that is +1 and then +2, which means y is x plus what? Which means it is x plus 3. And that is the equation. So, okay, what else are we supposed to do? So we found the equation of the straight line KO in the required form, mx plus c. It is exactly x plus 3, and x plus 3 is y equals x plus 3 is actually in the required form mx plus c. Now, a couple of things therefore become important. We need to calculate the length of kn. Right, the length of kn. So to find the length of kn, straightforward. K is coordinates -1, 2. So, okay, so this one is straightforward. You can just say the length of Kn, use the distance formula. You have the point K, we have the point N. So K has coordinates -1, 2. Okay. K has coordinates -1 and 2. And N has coordinates 1 and -1. So these is the same as x2 minus x1 squared plus y2 minus y1 squared. So Kn is x1, y1, x2, y2. What is x2? Is 1. x1 is -1. y2 is -1. y1 is 2. You square it. Okay, so this is exactly 1 plus 1, which is 2 squared, is 4. This 1 minus 1 minus 2 is -3. You square it, it's 9. So the distance here becomes the square root of what? The square root of 13 units. So the length of Kn is the square root of 13 units. All right, obviously you can return the square root of 13 units, but you can also give the length There's 3.61 units using the calculator. In 3.5.1, need to calculate the possible coordinates of L. Right, let's see that one. So to find the possible coordinates of the point L, it has been given a couple of marks there. Total of 5 marks. Okay, let's just do that one. Right, to find the possible coordinates of L, let me just clean up this section there. So we are looking at the answer to the question 3.5.1. So we will need first things first to be able to find the. Okay, it is further given that Kn is equal to Lm. Kn is equal to Nm. Here is Kl is equal to Nm. Okay. Kn is equal to Lm. Here is Kn is equal to Lm. No, not showing the right thing.
It's supposed
it doesn't
to be
look equal. Lm, this one. Right.
Yeah.
Okay, yeah, because I was wondering, it did not look equal to me. Okay. Right, so yeah, so we are actually saying yes, Kn is equal to Lm. Thank you. All right, so I was wondering, it did not look equal to me. I was wondering, yeah, but it's fine now. Okay, right, so with this, then we are good. And we just need to find the possible coordinates of L. And to do that, I'm just gonna do it, let me do it here. Let me do it here. Right, let me do it here. See where to get. So now for that one, we're gonna look at the answer to 3.5.1. Okay. So first and foremost, we're gonna do this and say x plus 3 squared plus y plus 5 all squared is equal to 13. We're gonna call this equation 1. Okay, because we already know that Kn is 13 from the previous question. Okay. We already know that Kn is the square root of what? Of 13. So if Kn is the square root of 13, well, it means that Kn squared is 13. And then you have that L is a point on KL. L is a point on KL. Right, so in other words, if you look at KL, you're able to see that L is a point there on KL. But we know that the equation of KL is x plus 3. We found it before. And we're going to call this equation 2. So now, if the equation of KL is y equals x plus 3, And then we find this equation here, that is the equation of a circle that is having center M. Okay, it's a circle. This, it doesn't look like one, but yeah, okay. I don't want to draw a big one, perfect one. It'll be much bigger to occupy a lot of space here. So you're gonna do substitution and then say substitute. Let me use the word substitute. So substitute equation 2 into equation 1. Okay. All right. Substitute equation 2 into equation 1. With that being said, you'll have x plus 3 squared plus y is x plus 3, so you put that one there. So it's going to be x plus 3, but there is a plus 5. All squared is 13. So you square everything here. If you square everything here, you square x, it becomes x squared. The next one is x times 3, 3x by 2, 6x. You square 3, you get 9. Okay, so this one can be looked at as x plus 8. When you square x, it becomes x squared. X plus x by 8 is 8x by 2, which is 16x. 8 squared is 64. 13. 2x squared plus 22x plus 60. Divide through by 2, x squared plus 11 plus 30. Get us of 30, that gives 11 would be 5 and 6. So you have these factors. All right, so this means you have minus 5 or minus 6. Okay, x is x plus 3, remember, so you substitute minus 5 plus 3, minus 2. Substitute to put minus 6 plus 3, which is minus 3, which is minus 3. So we therefore have the coordinates of L. L is clearly, so the possible coordinates of L would be x is minus 5 or y 2, or L will have the coordinates x is minus 6, y minus 3. Okay. So these would be the possible coordinates of L. 5 marks. Okay. And then you can do many other ways to do this. There are many other methods. Right, in 3.5.2, you need to answer the question that says, determine the coordinates of L if it is further given that KLMN is a parallelogram. So determine the coordinates of L. Right, so let's do this one right now. Okay, you're given that KLMN is a PARM, parallelogram, PARM. All right, let's clean up the board a little bit. So this one is nice and short. I'm just going to do it in that open space. And now we want to find the coordinates of L if it is further given that KLMN is a PARM. So I'm going to do 3.5.2 here. So now if KLMN is a parallelogram, the diagonals of a parallelogram bisect each other. So with that being said, we can use that property of the fact that the diagonals cut each other in half. They bisect each other. So we can be able to find the midpoint. The midpoint of KM. So this midpoint is -2. Let's find the midpoint of KM. Here's K, and here's M. Let's find the midpoint. Okay, let's use a formula. Okay, so we're practicing here. Right, so the midpoint there would be x1 plus x2 over 2, y1 plus y2 over 2. And then obviously we're dealing with the point K and the point M. So you can be able to find the midpoint. So this one is x1, y1, and this one is x2, y2. What is x1? -1 minus 3 divided by 2. What is y1? 2 minus 5 divided by 2. So -1 minus 3 is minus what? So exactly -4 divided by 2 is -2. 2 minus 5 is -3 over 2. Okay, so this is the midpoint of Km. So if we're to find, therefore, the coordinates of L, we can use, again, that property there. All right. So now, in other words, the midpoint will lie in the middle of this line here of K, of the line Kn joining L and N. Okay, so, and this would be -2 and -3 over 2. Okay, midpoint of the other line segment. So, which means we can be able to find x. We can be able to see that if this one has the coordinates of L, for example, and then the coordinates of N, for example, so we can say XL plus 1, you divide it by 2, it must equal -2. And then you take YL, so this one is XL and it is YL. So you also take YL, you add -1, you add -1, you always add, you divide by 2. It must be equal to the midpoint, the Y component of the midpoint. Right, so this is straightforward. So what is XL here? 2 times -2 is -4, -1 is -5. YL. 2 times -3 over 2 is -3, plus 1, -2. Be happy. So interested in the coordinates of L. -5, -2. -5, -2. Okay, so this will be the actual coordinates of L. All right, so we answered that question there. What are the coordinates of L? If it is given that KLML is a parallelogram, so you got that. Now, there are a couple of things that remain very important. Like, if you look at this question, 3.6, T is the point on KL produced. Okay. T is a point on KL produced. So you take KL and you produce it. There's going to be a point T on it. Now, TM is drawn such that TM is equal to LM. Calculate the area of triangle KTN. Okay? Well, it's an interesting one. Let's just take a look. Just create space and get cracking. Okay, this video is recorded, so these things will be available for you to watch later on. Okay, now let's follow the question. Try to understand what this is about. Yes, my dear. Yeah, fine, thanks, my dear. All right, my dear. Right, so we continue. Now, at this point, you see, we're looking at K at 3.6. T is a point on KL produced. Right, so if you have KL and you produce it, so here is KL and you produce it, you can either be produced further to the right or further to the left. You can either produce it like this, or you can either produce it the other way. But let's understand what the question is about, so in which direction. So T is a point on KL produced. TM is drawn such that TM is LM. TM is LM. Right, here is LM. And then there's TM. Okay, very likely the T is somewhere here. So that TM is LM. Okay, there you are. Right, so we have that TM is LM. Okay. Calculate the area of KTN of the triangle there. Calculate the area of the triangle KTN. So we have the triangle KTN. All right. So we have the triangle KTN. All right. Let's do that one for 4 marks. Okay. Right. So it's about length. It's about angles. It's about geometry. Right. So to find this one, we first realized that we're doing 3.6. So we're writing the solution to 3.6. First and foremost, what are the coordinates of the point T? Right. So you have been told that, for instance, in 3.5.1, you found the possible coordinates of what? The possible coordinates of L. Right. So you realize, therefore, that the coordinates of T would be the ones you found in the previous 3.5.1 question. So the coordinates of T would be this -6, -3. And they're coming from what we found from question 3.5.1. And then now you are dealing with KT. Right, so if you look at KT, if the coordinates of T now are from the previous question from 3.5.1, you got them. And now we put them here, and the -6, -3. And then now we can be able to find KT. So the distance between K and T, we're going to say it is exactly -1, minus into -6, 2, minus into -3. Then you do everything, you get 50. All right, so the length of KT is the square root of 50. The Kn would be the square root of 13 This one was found in 3.4. We found Kn to be the square root of 13 units. Eons Kt is the square root of 50 units. Okay. Now, we need to find the area, and the angle there is clear. So you can use the trigonometric area formula. And the area of triangle KTN is half KTKN, the sine of LKN, area of triangle KTN is half KT. What is KT? It's the square root of 50. Kn is the square root of 13. Times the sine of LKN. Right, so the sine of LKN, LKN is the sine of 78,69 degrees. So area of triangle KTN. And this is 12,50 square units. So the area of triangle KTN is the 12,50 square units. Okay, we found it. That's what I wanted, and we're good. And that takes us to the end of 3.6. What time did we start?
So we started at 11 minutes past 8.
And what is the time now? Do you know?
The time now is 16 minutes past 9.
Right, so it is exactly 9:15.
Yes.
Right, and I'm going to call it a very good evening, I believe. Okay, it's just above 1 hour. I have the luxury to do more. I'm going to do more tomorrow. Okay.
Okay, sir.
Yeah. Okay. Just about 1 hour. 4 minutes extra. Okay. All right. So we're good. Right. So I will see you tomorrow. At the same time. You suggested Friday and not Saturday, but you let me know about it. Okay. I'm going to send this video to you, the link in a few minutes now, but first I will have to upload it and then send you the link so that you can watch. In watching, you copy down the questions and you copy down the solutions, and then you cover the solutions and look at the questions and make sure that you can be able to get the answers on your own to these questions. I'm going to be doing more tomorrow. Okay.
Okay.
Or yeah, tomorrow or Saturday. So you let me know, because tomorrow is Friday or Saturday. Yeah, you let me know. But
no,
yeah,
tomorrow. Okay. Can we do it tomorrow?
All right, that's fine. Okay, tomorrow. Okay, thanks then, and have a good evening. Okay, I'll see you then. Okay, I'll keep you posted with the video. All right.
Okay, bye, sir.
Thanks then. Goodbye, dear. Goodbye.